Because of this pattern, a vertical column of elements is called a group. There are altogether 8 main groups. Each group has a number: group 1, 2, 3, 4, 5, 6, 7 and 0. Finally, the follow elements are transition metal. We should note that group 1 elements have one outermost shell electron, such as hydrogen and lithium. Group 7 elements have 7 outermost shell electrons, and so on, such as fluorine. For example, elements in group 1 have 1 electron in their outermost shell, whether it's lithium, which has 3 electrons overall, or sodium, which has 11 electrons overall, and if this feature that gives all group 1 elements similar properties. For example, group 1's elements have similar chemical properties. Also, they react violently with water, and become more inactive as you go down the group. In the last video, based on the Boas model, the electronic arrangement of potassium should be 2, 8, 9, however, it is incorrect. Potassium should be arranged in 2, 8, 8, 1. We can learn how to draw them with the help of the periodic table. Potassium under the same group will have the same number of electrons in their outermost shell. Potassium belongs to group 1, hence, its outermost shell will have 1 electron. To draw potassium's electron diagram, we can first draw its outermost shell with 1 electron, and then follow the formula to complete the inner shell. In the end, we will get 2, 8, 8, 1 as potassium's electronic arrangement. Calcium in group 2 have 2 electrons in their outermost shell, and so on. We use similar method to arrange the electrons. Therefore, the electronic configuration of calcium will get 2, 8, 8, 2. Some groups have special names. Elements in group 1 are known as alkali metals. Elements in group 2 are known as alkali earth metals. Elements in group 7 are known as halogens. These elements become less reactive as you go down the group. And elements in group 0 are known as the noble gas. They all have full outer shells, so argon, which has 3 shells, has 8 out of 8 in its outer shell, shown on figure 1. While helium, which only has 1 shell, has 2 out of 2, because if you remember the first shell, it can only hold up to 2 electrons. All noble gases have 8 outermost shell electrons in their atoms except helium. They will become stable if they attain a doublet or an octet, because they don't need to gain or lose any electrons. The noble gases are all very unreactive. Atoms of elements other than noble gases are usually not stable. Beside that, the elements in between group 2 and group 3 are called the transition elements, or transition metals, such as iron and copper, are transition elements, and they do not belong to any groups. Sometimes you might see a zigzag line running here from aluminium to polonium. This line separates elements into metals, which includes everything to the left side, from the non-metals to the right side. Some periodic tables will display hydrogen in group 1, because it has 1 electron in its outermost shell. Just remember that it is non-metal. We will take a closer look at the elements in groups 1, 2, 7 and 0, as well as the difference between metals and non-metals in another video.